Alright, so in this video we're going to talk about the remainder theorem for polynomials. The remainder theorem says that let f be a polynomial function. If f of x is divided by x minus c, then the remainder is f of c. Okay, so we're talking about dividing polynomials, and there is a kind of a shortcut for this. Alright, so again, if we divide a polynomial by something in the form x minus c, it has to be in this form. Then we can say the remainder is just going to be f of c, and that would just mean plug in c into the function and evaluate, and you would get your remainder right off the top. All right, so that's going to save us some time. I will go the long way, and then I'll show you the shortcut, just so you can do the shortcut each time. All right, so let's look at this example. We've got x cubed minus 4x squared minus 5. If we wanted to divide that, if we wanted to take f of x and divide it by x minus 3. What would that look like the long way if we were supposed to do this the long way? Well, we would do what I did last time, and we would create a box. Now, you will need to use this box in the future, so it's good practice, but there is a shortcut for for certain instances, right? So I've got x to the third minus 4x squared minus 5. So let's just write this out. X to the third, I'm going to circle that, minus 4x squared. I just don't want to forget any terms. How many x terms do I have? 0x. And how many plain number constant terms I have? 1. So there's actually 4 terms, even though one of them is just the 0x. It's not written there, but it might pop up. So I want to keep track of that. Now I'm dividing by x minus 3. That's the factor I'm dividing by. We're going to essentially see if it is a factor. All right, so I'm trying to get x to the third, so I write x to the third. That's the first term. This would then have to be x squared. X squared times negative 3 is negative 3x squared. I need negative 4x squared. I've already got negative 3x squared. Right, this one's taken care of. So I need one more negative x squared terms. All right, so then this would be negative x. Negative x times x is negative x squared. Okay, so this would combine to give me this term. That's good. Negative x times negative 3 would be 3x. Now it looks like I need 0 x's. I showed that x's popped up, but I don't need any of them. So I'm going to get rid of these 3 by putting negative 3x. Okay, that'll cancel those out. And this is where it starts to break, because I don't have anything I can multiply times x to give me that. Oh, I lied. I've done too many of these in a row. There is something. Simple. Negative 3. Negative 3 times x is negative 3x, certainly. So then these two would cancel, giving me 0 x's. That's perfect. Negative 3 times negative 3 is positive 9. I guess I need more room. What else would I need? I need the negative 5. So how would I get negative 5 if I'm already at positive 9? Well, I would certainly need to subtract a whole bunch of numbers. I could subtract, let's see, what would that be? I would need to subtract 14, minus 14. 9 and negative 14 would make negative 5, but here's where it breaks. This turns out to be my remainder. Okay? This is my remainder. Now there's a shortcut. There's a shortcut to this, and that was the whole point of the remainder theorem. And that says that if it's in this form x minus c, and it is x minus 3, then f of c is going to be the remainder. So let's test that out. What would f of c be? Now it's not negative 3, because it says x minus c already. So it's minus 3, meaning c would be 3 in this case. Well, what's f of 3? So we just plug in 3 for every x value here in our function and evaluate it, and we should get negative 14. So let's see. 3 cubed minus 4 times 3 squared minus 5. Here's where a calculator can come in handy, because you could plug all that into the calculator, and you would get, let's see, this would be 27 minus 3 squared is 9 times 4, which is 36, and then minus 5 again, giving you negative 14. Why would we do this? Well, this is certainly a lot shorter. This is a nice shortcut. It is shown and proven in your book, so f of 3 is negative 14. So we will use this fact. We will use this fact in our next video, but essentially, if you're dividing a polynomial by x minus c, it's got to be in this form, so not helpful for every single one, then the remainder is going to be that. Okay, and in the next video, we're going to look at what happens when the remainder ends up being 0. And that's going to help us save some time when we're actually finding roots and factors.